Had some good sessions. I know we did our best to pull together some good speakers to share the sort of the best and the most interesting things that we're seeing in market, and I hope to extend that today. So the session that we'll go through is talking about data lakes on AWS. Now, I think probably all of you have heard about data lakes, and you're in this room because you're curious about what is it really and how do we build them. So what I'm going to share with you is, as we look across some of the most interesting customers that we have, and the big customers and the small customers, how are they approaching this idea of there's a whole lot of data that there's something interesting in it, but it doesn't play nice in a traditional environment. So I'll give you a little bit of background about why I care about this so much, and then we'll dig into what best practices look like. So as you may have heard, my name is Craig. I'm based out of Singapore. I've been in Asia almost 20 years, and I've been working in the analytics industry for about that same amount of time. I come from a behavioral analytics background, and at that time, so 20 years ago, we were doing analytics, right? We were processing data in big scale, but it tended to be a few companies that could afford the very specialized skills of, we called them data miners at the time, and they could afford really big hardware. Well, the way that we solved problems at that time was by buying really big boxes, right? And so when we worked with the casinos, when we worked with the banks, and we worked with some of these really large organizations, then they had to buy super huge infrastructure just to get started. Now, that's changed a lot, and what's available to you today looks very different than it did several years ago. So we'll kind of talk through a little bit around how this stuff actually fits together to solve some problems. Now, we like to put Netflix up on screen, not only because we love to watch Netflix, but Netflix is very interesting. And part of the reason that we hold them as such an interesting customer, Netflix does things that just have never been done before at the scale that they operate. So Netflix at peak, you've probably heard something similar to this, is at peak consumption in North America, they consume 38% of all internet traffic. Whew, it's huge, right? What that also means is that they are looking at the amount of human behavior that they track is pretty extraordinary. Now, in order for Netflix to operate and be as successful as they are, they have to give great content recommendations. And those little bars that you see at the bottom, those generate about 80% of all views of Netflix content comes through recommendations. Now, how do they get good recommendations? They build a couple of insights. One is they look across everybody who's watching, and they build things called cohorts. People who look like other people, and they start to then build profiles around what kind of mood might you be in. So based on your cohort and looking at, do we think that, are you pausing a lot, you leave for 3 minutes, you come back? I don't know, maybe you've got small kids in the room and they're kind of distracting you. Maybe you're bored and you've gone to do something else. They do something called playback analytics. And playback analytics is the process of capturing these sort of interesting winding streams of human behavior, of how people watch and they consume video. That doesn't fit into a data warehouse. So for Netflix to be able to produce not just these two recommendation bars, but to build the hundreds of recommendation bars that sit underneath, they have to be able to capture every single bit of data, even when it doesn't look like nice transactional data. So they've built a data lake that operates now into the hundreds of terabytes and into petabytes in some of their, because they have sort of distributed data lakes. So Netflix has to move over to, and we'll talk about the design, but they have to move to data lake to be able to operate at the scale that they do. Now, if there's any gamers in the room, we're all friends, you can admit it. So yeah, Clash of Clans, it was a huge game. For 6 years, Clash of Clans was the #1 daily revenue earner of all mobile games until Pokemon Go, right? So anyway, but until then, for 6 years, it was the #1 earner. And why? Clash of Clans, and Supercell specifically being the company that runs them, is able to detect your mood. So as you're gaming and you've died 3 times, they know if you're a person who's going to get frustrated and you're likely to leave. And if you are you competitive? Are they going to put up something like a leaderboard? Are you a social person? Are they going to put up, here's somebody who's recently come online who's a friend of yours? Are they going to say, here's the next level, here's how far you need to go to get to the next level? If you watch other people who are playing, they'll be getting different sorts of indications, things that are going to trigger them to stay in the game. These are things based off of your propensity, and then you're basically looking at your behavioral profile. In order for them to capture that and detect that, again, this is not nice transactional data. This includes things like your location, GPS location. It looks at your behaviors within the game. And more importantly, what's captured in that data lake needs to build models that are in the hundreds of milliseconds for response time. So when they detect that you've changed your state, they're able to give you some sort of recommendation that happens within hundreds of milliseconds. So how do they start to build this? Let's walk back a little bit and think about what's changed. Why data lakes look fundamentally different from what we had years ago. Now, kind of 1985, before I think the majority of us were in tech, we had this idea of buy big boxes and solve big problems. And these were data warehouse machines. They typically were hardware that had some software integrated, pre-configured to run at an optimal level. And that held for a whole bunch of years. That held for about 30 years. About 20 years. And so that sort of held until about mid-2000s, when a big internet search company had this problem and said, buying big machines is not going to solve this, so I need to take this problem of searching the web and break it down into a lot of small parts. And sort of that was the genesis around that time of creating Hadoop. And if you're not familiar with Hadoop, this is important for a later discussion, because Hadoop takes this idea of big problems, split them into a lot of small pieces that could be asked at the same time, and stick them onto cheap hardware. It lets you scale out, and it essentially buys you time so that you're able to solve really big questions in a shorter amount of time. That was good, and Hadoop was really useful, but if anybody here has ever installed and managed a Hadoop cluster, I'd like you to smile for me. It's terrible, right? So it's okay if you're operating at a small scale, but when you move past 8 nodes or 16 nodes and you're doing patch management, and it's just kind of like it's a pretty miserable process. And so we got a lot of feedback saying, can you make this process easier? So we decoupled the storage and the compute. Because fundamentally, when you're building Hadoop and you need to extend your clusters, it's never because you run out of compute. It's because you run out of storage. You need more disk, you need more HDFS, you need to put more in, so you're buying more machines. You're basically buying like big computers just for the disk, which is really great for you. So we split out with our Hadoop implementation called Amazon Elastic MapReduce, or EMR. We created something which is a decoupling. It was the EMR file system that allows you to store all your HDFS in S3, and then you can turn that cluster on, you can turn it off. If you want to scale it, you can scale the cluster up and down, and you're only paying for the hours that you run compute on. This totally changed the model of how people thought about using Hadoop. Instead of it being the place where you store data, it became an engine to process data. I'll say that one more time. Hadoop's role changed from being the place that people thought about being a data lake into just an engine to process data, with the storage becoming the data lake, the storage being the place where the data lives. Because if you're paying S3 prices, which are I think around 2.5 cents per gig per month, it's very different than having to buy disk on a whole bunch of machines. So this process of thinking differently around where does storage fit into this bigger picture. And I won't go through all the sort of details, and I'll talk a little bit later about Redshift and how we're actually moving more and more towards not even running servers at all and moving towards serverless and clusterless services. So I'll talk about those a bit later. Now, kind of the next big shift that came out of this was, not only are we moving away from this idea of buy big integrated machines to solve problems because they don't scale well, but also this idea that what if we could decouple better? What if we could create data pipelines? So instead of having these huge batch jobs that have to run to move data from source A into target B, we could say every time that there's a change in data, let's start streaming through data in data pipelines. It typically follows a pattern like this. You have data that's it's ingested, it's stored, analyzed. We sort of cycle it a couple times and then it's consumed. And what you'll see is that this changes the whole economic model of how data flows through a system. You don't have to provision 3 years in the future. You're only paying for what you're using in that moment. So again, a very different model around thinking about how to move that data. And it tends to be represented like this. As you look at sort of AWS customers that are operating at scale, they tend to structure their data flows into data pipelines and event pipelines. So data pipelines sit across the top, and if you come from a data architecture background, you may be familiar with this concept of Lambda architectures. Something similar to that. You have a batch layer and a real-time layer. But essentially, you have data pipelines and event pipelines. The data pipeline moves source data all the way through to some sort of data processing facility that then the user is able to pick up. So what does that pipeline actually look like? So it's a fully decoupled system, ideally. Starts with Amazon S3, which we mentioned, simple storage service, which is that really durable 11 nines of durability, so you never lose objects. It comes out of the box with things like tick box encryption. You've got versioning. You're able to stick this stuff down into cold storage. It's okay. So things land first into a landing zone. This is very different from batch loading things from a source into a database. We first put it into an object-based store in a landing zone. There's a trigger that runs off the bottom, and that trigger says the moment that I see new data, the bucket's responsive, and it runs a bit of code and says, okay, I've got something, push this down into the data processing layer. The data processing layer, in this case, we see customers that operate at scale, they often prefer to use Hadoop with Spark. There's some libraries that are good for processing semi-structured data and processing data at scale, which is, if you look at Nasdaqs and FINRAs and our very large customers, they tend to use this model. If you're smaller, you may choose just to use something like a Lambda script, or you can use Talent or Matillion. It doesn't really matter. The important thing is it's part of that pipeline. Now, there's a bit that sits on the bottom now. So we've released a service called Glue, and Glue it does a few things for you, and I'll talk a bit more in detail, but essentially it's helping you run your ETL jobs and keep track of what data has been produced and where it's stored. That data then goes and lands into the data lake. The data lake, again, is another S3 set of buckets. Now, once it's in the data lake, whether you push that into a data warehouse, or it goes into a NoSQL store, it goes into Elasticsearch, wherever you want to consume it, the important thing is we put the controls and the access controls and governance at this layer into S3. So one of the core services we mentioned, if you're not familiar with Glue, this kind of takes away some of that heavy lifting of, okay, I'm storing stuff in my data lake. How do I catalog it in a way that I can search and find it? So Glue has 3 parts to it. Glue does crawling of data, which is my data's landed somewhere. Please tell me what the shape of it is. What are the fields? What are the data types? Is it numeric? And so on. So it helps with that categorization of data. Then there is the ETL execution, which does what it sounds like. And then the third is cataloging. Now, the decision was made, if you've ever done data catalogs before, the format that's often used are Hive metastores. And we've chosen for Glue to also use a Hive metastore so that you can sync, if you have existing catalogs, you can sync it, or if you have other management tools that you like to use, you always have the ability to move to and from Glue. So you don't end up getting locked into any given tool. So the idea behind a data lake, why we're building it, is much of it is because we have those types of data like clickstream behaviors, we have geolocation data, we have anything that's really coming off digital assets doesn't play nice in a data warehouse. And if we're getting third-party data or data in from API services, it doesn't play nice in the data warehouse. So we need to be able to build something that can handle transactional data, handle ERP data, handle social media data, can handle video files, audio, whatever it is that we need. The data lake needs to be able to support that. The other is, if I look across this room and we did a survey around your technical skills, there's going to be people here who are super hardcore data analysts, probably even up to the data science level. And then there's going to be people here who are just curious, who don't even write SQL, right? So there's quite a range, and it's all people who have needs for information. So the data lake needs to support different types of tool access. It cannot only be available for one type of role. So again, thinking about role-based access to the data. So diving in anywhere, depending on granularity, and having good search mechanisms so that we can know what's in the data lake, what's been vetted, when it was updated, and so on. So what it looks like. This is kind of a bit of an eye chart, but it's looking at the services that tend to be used to build the data lake. S3, and then there's the ingestion layer. We mentioned this before, but because we've been building the cloud for a long time, since 2006, we have a lot of mechanisms to move data into the cloud. So whether you're using storage gateways, if you're in a regulated industry where you can't ever let your data move across the internet, you might use a bit of fiber that goes from your data centers to ours. It's called a direct connect. There's many ways that you can move data in. We also have the consumption. Now, the consumption, there's a whole lot of tools. This is by no means comprehensive. Data warehousing, Elasticsearch, direct query capabilities, BI tools. So there's a lot of ways, and you can even bring your own if you're a Tableau user or a Qlik or a MicroStrategy user on that side. Now this part is super important for making sure the data lake has the right controls so you can find out what's in it. There's a service called Macy, and if you haven't heard of Macy before, Macy is an AI-based data categorization and data classification tool. That was a big mouthful. I'll try it again. Macy looks at data and it tells you, is there PII? Is there personally identifiable information? are their national ID numbers, are their phone numbers, are their addresses. It can also look for if you have other things that are sensitive to your business. You can write rules for it. But it learns. It's a machine learning based AI tool that once you've said this is the kind of data I'm looking for, it can also learn and improve over time. This is helpful if you say have data that's coming in, you think that it's got certain content, but you want to validate it before it drops into the data lake. You can put a level of protection on that. So you can check that data. In addition, you can use it to say from a data loss prevention standpoint, somebody who's coming in accessing the data lake, you can always make sure that when they've merged together data sets, they haven't created something that should not be exported out of the system. So Macy helps you with some of the tricky data classification and DLP sort of issues. There's also Glue, which we talked about, which is really around being able to categorize what's in the data lake, how did it get there, and if you're searching for it, what the rules are around that data. There's another piece for access, and without going into sort of each one of these, it's essentially whether you're coming in through a mobile interface, you're coming in through your computer, you're coming in through different servers, being able to apply access controls based on role. And at the bottom, this is really around securing access to the data sets. Why we focus so much on applying this governance to S3 is that if we apply it at the data lake level, then it doesn't matter what tool people bring. And in the old world, what we had to do was every single access tool, we had to apply security controls into that tool. And it's a little hard because you can never keep that in sync, especially as you add tools. So if we put programmatic controls, if we put role-based access controls at each bucket level, we can ensure that no matter who comes and accesses it, what tools extract from it, they have to follow the same rules. Data cannot be used improperly or can be accessed by people who shouldn't see it. So the downstream service that you'll almost always see tied onto a data lake. So you have data lake, which is typically just from a structure, if you're curious about that, double click down. Typically we see data that comes in, gets stored into a columnar format. So for those who aren't super interested in this next layer down, you can kind of check out for about a minute. But for the ones who want to know, like, what does it usually look like? Typically it's a columnar format. It gets stored in, there's three kind of main formats we see, whether it's Avro, Orc, or Parquet. Parquet seems to kind of be winning the battle just because it's consumable by number of different downstream services. And one of those services being the ability to import that into Redshift. So Redshift is a data warehouse, and data warehouses are good at answering dimensional questions. A dimensional question is what something looks like over time, or a person's purchase history. Basically, you've got a set of tables, and they sort of look across those dimensions. It's called a schema. And if you know what your schema is, a data warehouse is great at answering those questions at scale and at speed. But you don't always know the schema that you want. Sometimes you want to ask questions, ad hoc questions. So I'll go a little bit deeper on that. Now, here's the pattern. Now, you saw before we had the consumer, we had the source, and then there's the pipeline that sits in between. What Nasdaq is doing is Nasdaq is looking at a whole lot of queries that come in through the day, and they insert, this is 4.8, but they vary between about 5 and 8 billion rows that need to be added to the database. And Nasdaq, of course, being the tech exchange for stocks in the US. So they have a whole lot of challenges. They have a lot of challenges they need to look at, and one of them was, if you remember back in, I think it was around 2008, Goldman Sachs had their high-frequency trading system kind of went berserk, and there was a flash crash, and they had to shut the markets for a bit. And that wasn't a great result, so Nasdaq was tasked with, can you please find intraday anomalies? And their existing systems, they couldn't. So they just had to shut markets when things look weird. So by building a data lake that they can then apply any sort of, whether they want to run a 1,000-node Hadoop cluster to do data processing at night, or they want to do intraday loads into the data warehouse. So this is where you'll see the data coming in from source, goes into a data lake, and now it feeds into EMR for data processing, and it goes into Redshift for trend analysis. So again, that same sort of pattern, we see it replicated across a number of our customers who operate at scale. Now, let's say that you want to look at data that doesn't all need to be hot. So most industries say, okay, well, sometimes I work in a very high volume business. I only care about what's happened in the last 6 months typically. Anything beyond that, I might do annual reporting for seasonality, or I might want to look at data that's historical data, but I don't want to pay to have all of that sitting in the warehouse. So what we've introduced is something called Spectrum, which is kind of like it's a cold tier for your data warehouse. And what this means is that a person who's issuing one of these dimensional queries to say, hey, can you show me all my trends over time, they don't have to write multiple queries. It goes into the warehouse runs and says, oh, I've got 6 months that's hot, and the rest of it's aged out in the data warehouse. I can now just pull and run the query, and there's a little bit of a performance hit, but the benefit is you can store as much as you want historical data, and S3 is essentially unlimited, and all you're paying is storage cost until the moment you query, and you pay for query execution time. It's a totally shreds the model on how much you're paying for data that is kind of dark or data that you don't normally query. So again, just optimization models that a data lake opens up if you're running a data warehouse. And this is how Cisco, so Cisco, if you're not familiar with them, they're kind of one of these huge companies that sits behind the scenes. They're one of the largest food distributors for aircraft. So if you see like the Sky Chef's trucks that go and they stock planes, these are the people who bring them the food. Food into hospitals, food into a number of different industries. So Cisco is looking at food distribution essentially. So they pull data out of AS400. So they've got all sorts of legacy infrastructure. So it comes out of those systems, pulls into that staging layer, goes through some ETL. They choose to use Redshift to do some of the data processing just because it operates great at scale. Move it into a data lake and it's consumed by Redshift for doing these very, very large historical data queries. So again, just sort of an example of how these services tend to stitch together in a pretty recognizable pattern. Now I mentioned before that you've got dimensional queries, which is I know what I want to ask before I load the data. Like I want to ask about my customers, my suppliers, I want to look at some demand forecast, but sometimes I'm getting log files and I don't have a schema. I don't have preset questions that I know I want to ask. I want to explore that data. So direct query tools, something like Amazon Athena, that data just lives in a columnar format sitting in the data lake. And you can come and just ask it a question. So it's been registered in that metastore and in those catalogs. Athena comes in and says, what are all my available data sources? Come in and query that directly, and you can do exploration without having to load data and without having to pay for a cluster. So how does this kind of all stitch together? So we still have the same lady, the data analyst who's sitting on the right, and maybe we'll say that she's a financial analyst. So she's got some SQL skills, and she uses Tableau typically. Data sources will live in some sort of transactional ERP system. So let's say in this case you've got maybe Oracle sitting in financials, and you've got an SAP R3 system. We have a number of different ways to import that data into the cloud. And this is just a very simple example, but there's many, many of those. You can kind of bring whatever you want. We have 2,900 products that are sitting in our marketplace. You'll probably find one that will help you export from whatever data source you have. In this case, we look at maybe the Oracle data pump. That's fine. We can use that to move data from Oracle into S3, a common pattern, or maybe coming out of R3. R3 is sort of notorious for having all sorts of crazy tables with German names, and it's super hard to decipher. So Bright, one of our technology partners, has worked on fixing that problem. So to be able to do a sensible extract out of R3 into S3. So again, just sort of picking a couple tools to pull that in. It lands into a landing zone, and then it gets loaded into the data lake. Now, we've already looked at what that data pipeline looks like on the double click. So this is just a simplified view of that. At which point, she has the questions she knows that would be answered on a monthly basis, which are her dashboards, and she might use Tableau to access those. She might then use Tableau also to go to Athena for data exploration. So without the users having to change their tools, they're able to just issue queries down against the underlying services in the most suitable way to access the data lake. Now let's look at a different user. Let's say we have, that's fine for a financial analyst, but maybe we've got a business user who doesn't write any SQL, doesn't have any sort of knowledge of that sort of data structure. He might look in the data lake and he's saying, okay, well that's fine if I look at maybe customer patterns that I've observed through transactions. What if I pull in social media data? Where does that come from? So event streaming. He first looks in the data lake. The transactional data, I've kind of simplified that Oracle data pump and so on, but you have the batch data that loads across the top. Now event data, and I haven't put all the icons up here, but if you're curious, what that typically looks like is event data is fundamentally different. Streaming data is different because doesn't come in these nice sort of tables. it's sometimes out of sequence, and you have to build windows and make sure that you've captured a full event before it gets loaded for analysis. So there's a little bit of nuance. So typically they'll run Kinesis streams to capture that data. They may even run a very, very small 4-node Spark cluster and use the Scala libraries to do some of that data windowing, but essentially packet that and then move it up to the data processing layer. Now he may use, again, a data warehouse for running his reports out through, say, QuickSight. Or he might use Kibana on the backside using Elasticsearch if he's looking at understanding stream data or looking at events that are in flight. So I'll simplify that one more time. So you all kind of know there's some icons underneath. I just don't want to drown you with it. So we'll just kind of simplify. Essentially, the architecture tends to look like batch data and event data at some point rolls up and gets put into a data lake. However, here's the reality. That's fine if you're just saying loading data for reporting. But what if you want to load data, and you say, before I just make a data swamp of capturing the entire Twitter universe and storing that in my data lake, which is crazy, and sometimes people will have an idea of we need to capture all the data. Actually, a better pattern is when you start to sample new data sources and your data scientists need to build models, we create a layer in between, and it's called a sandbox. And so sandboxes are, again, it's a data store where new data that's coming in can be tested, hypothesis can be tested. Is there a correlation between when somebody pauses a video and they come back 3 minutes later and their mood? Like, I don't know, I want to test that. I want to run some data science against that. I want to be able to run different sort of analytic models against that. So it gets stored into the sandbox. The data scientist is then able to use tools like whether it's Spark ML, whether they're using SageMaker, R, SAS, whatever it is that your tool of choice, runs against that sandbox. And if it's good and models that have some weight, some significance are created, the output data sets, not all the raw data, the output data sets are published to the data lake. It's a very different model than sometimes where people say capture everything, store everything, and then you hope that there's value in it. Using that sandbox to say vet the data, only publish the scored data sets, and then only the source data that had that business relevance, that's what publishes to the data lake. This strategy is what helps companies not end up with these massive stores of stuff that's useless basically to the business. So again, this sort of vetting and publishing process. Simplify it one more time, we'll just call that the ML analytics layer, and this is just kind of a simplified view of that. Now, you want to use AI services that are really cool. Like there's all sorts of stuff that we've invested in bringing to market around language services and vision services and so on. Now on the event layer, initially, that data scientist has built something, not just scored data sets, but they built something called predictive models. And a predictive model can be published in either, say, a PMML format, or if it's neural networks, it might be ONNX. But essentially, they take that model and they move it down into a layer that is responding to events. So an event will happen. Now the event continues to be captured to look at patterns over time, but then there's a response to it. There's a little Lambda trigger that pushes it up to a scoring engine. Scoring engine says, oh, based on this, should I give that person a leaderboard, or should I give that person something else, like maybe a social response? And then there's another little Lambda trigger that says, now that I have that answer, I go down to the action layer. Now, when you're integrating with your systems, let's say that you're in ad tech or gaming or something that's you're running mobile apps and you need very fast response, you'll publish that out to a NoSQL data source like DynamoDB, and then the app polls that. That tends to be a really low latency pattern. Or maybe you've got a queuing system and you just need, as soon as you get a response, you fire that out through SQS or something like that. So again, there's a few different connectors that sit on the sides, but if you kind of want to peel the covers back and look at how our big best customers pattern the use of data lakes within a bigger architecture, it tends to look like this. So I'm going to close up in just a minute, but what I want to leave you with is you don't have to sort of build all of this on your own from scratch, because there's a little bit of nuance underneath in how you build access controls and how you put together some of the searching and cataloging features. So what we've released to market is something called a solution builder. And you can either write down that link, or easier, it's kind of the easier one, is you can just search for that title on the web and it'll pull up. So look for AWS Data Lakes. And what you'll download is a set of CloudFormation templates, which you run inside of your account, and then that will just get the initial framework set up for you. You can take that and you can test it, tweak it, see if that's a good starting point for you, and at a minimum, you can look and see how we've seen that as a best practice, and then you can choose to learn from those patterns. So, what I recommend for getting started, and this is just my own experience of having worked with customers across a number of our regions, step away for a little bit. Just sort of step back from this idea that the way that you succeed with a data lake is capturing everything and then question mark profit. Just step back from that for a minute. What we see as a more successful pattern is shortlist a set of projects, and specifically projects that have some sort of baseline metric for how your customers love your product or service, how they respond, some sort of baselineable metric, because then when you load that first set of data through a pipeline and you load that first bit into your data warehouse, or into the data lake, you can test. You make a change to your operations and you can test and see, is this affecting my customer response? Is it giving a better customer experience? The reason I recommend that is those projects ripple really well through the business because they matter to the business. So starting with a short list of projects and then incrementally build your data lake as opposed to starting with a big bang. Second is data pipelines will probably be new for people. Again, if you start small, it gives you a chance to learn at a small scale before you start to move up to bigger and bigger, more complex challenges. And the third is we invest a whole lot in resources for you, like we have solution architects. You can talk to your account manager. This is the person who comes in as sanity checks. As you're building your design, the SA can come and say, okay, that's a good pattern, or I don't know why you're doing it that way, but you can have a good adult conversation with them. And if you need hands-on keyboard, we have partners and we have professional services to help you with hands-on keyboard. So with that, I want to thank you, and I do want to invite to stage to share with us Mr. Purnesh Gali, who is the head of Big Data and IoT Analytics as part of Group Data Analytics Cell. He's with Aditya Birla Group, and he's going to share with you their journey on how they have been building data lakes. So with that, I want to thank you very much. I hope you guys have an awesome conference. Thanks.